Please start. Yes, beta, we are going to find the derivative of fx equals to 10x. The function given to us is 10x. We are going to find its derivative. So its derivative using first principle we are going to calculate. So fx is 10x. Fx plus h will be 10x plus h. As I've told you already, keep in mind wherever x is written, fx plus h, x will change to x plus h. X will change to x plus h for the case of fx plus h. Now we are going to find the derivative of fx using first principle. So it will be limit of h tends to 0, fx plus h minus fx whole upon h. So fx plus h is 10x plus h minus 10x whole upon h. Now 10x plus h can be written as 10x plus h can be written as sine upon cos. I could write. So sine x plus h upon cos x plus h minus sine x upon cos x whole upon h. Taking LCM in the numerator, cos x plus h into cos x. It will become sine x plus h cos x minus cos x plus h sine x. Now see, it is sine a cos b minus cos a sine b. So that is said as sine x plus h minus x whole upon h cos x plus h cos x. Now see, x to x will get cancelled. Sorry, I forgot to write limit of h tends to 0. Sorry. Now see, it is sine h upon h, that is 1 cos x plus 0 into cos x, that is 1 upon cos square x or sec square x. So the differentiation of 10x, differentiation of 10x is sec square x. The differentiation, the derivative of 10x is sec square x. So this is one of the very, very important question. It used the differentiation with the simple techniques. I suppose this thing you will be able to understand in the best manner. So take care of this. This is differentiation with the simple methods, means simply we will be learning the identities, the formulas we are going to learn. So now keep in mind, first of all, the thing is ddx of a constant. ddx any differentiation of a constant. ddx is standing for the differentiation. So differentiation of a constant is 0. Differentiation of a constant is 0. Till now, we were doing the differentiation using the first principle. When we were differentiating a function using first principle at that time, that was, you can say, that is the derivation. Now, simply we are learning the formula. It will help us to solve the differentiation in the best and easy manner. On the basis of this question comes 1-2 marks. Differentiation of x to the power n. Differentiation of x to the power n is n x to the power n minus 1. X to power n will be having differentiation n x to the power n minus 1. On the basis of this, some of the questions, I must show you what kind of questions they may ask. So that help will be over here. Like differentiation of x. See, it is x to power 1. So 1 x to power 1 minus 1. 1 x to power 0, that is 1. So differentiation of x will be 1. Differentiation of x will be 1. Now, ddx of 1 upon x can be said as differentiation of x to power minus 1. So it will be minus 1 x to power minus 2. So minus 1 upon x square. 1, I am taking differentiation of root x. Root x can be said as differentiation of x to power 1 by 2. Keep in mind, we are applying this identity. So it will be n, that is 1 by 2. X to power 1 by 2 minus 1, that is minus 1 by 2. Now directly I'm writing, I don't want to waste the space. So it will be 1 by 2 root x. So hope you are able to understand that we could do this very easily. We can easily differentiate some of the things I have shown you, that is x derivative, 1 upon x ka differentiation, root x differentiation. So these three things we are able to differentiate very easily. I don't think now it is required to go for differentiation of x square will be 2x to power 2 minus 1, that is 2x. Sometimes one more special case I must show you, then we are going to the next step. We have been given y is equals to 2x square plus 1. We need to find its derivative. We need to find its derivative at x equals to 2. So point derivative at a particular point, we are going to find the derivative. So first of all, we need to find dy on dx will be 2 times differentiation of x square plus differentiation of 1. 1 is said as constant. So the differentiation of constant will be 0. Differentiation of constant will be 0. 2 differentiation of x square will be 2x. So altogether it is 4x. Now we need to find it at 2. So that will be 4 into 2, 8. So the result of differentiation 2x square plus 1 at x equals to 2 is 8. This derivative is giving us result as 8. So now we are able to remember at least two identities. Differentiation of constant is 0. Constant could be 1, 2, 3, anything like that way. It could be ABC also. Differentiation of x to the power n. is nx to power n minus 1. You must learn these identities, these formula you must learn. Without remembering, without learning, you will not be able to do these questions. We must move to the next. Now I'm going for the trigonometric ratios. So, color change. Differentiation of sin x. Differentiation of sin x will be cos x. Differentiation of sin x is cos x. Differentiation of cos x is minus sin x. Differentiation of sin x is cos x. Differentiation of cos x is minus sin x. Differentiation of tan x is sec square x. Differentiation of cot x minus cosec square x. Differentiation of sec x is sec x tan x. Differentiation of cosec x minus cosec x into cot x. Now see differentiation of the trigonometric ratios which are starting with C. Differentiation of the trigonometric ratios which are starting with C is negative. These are giving us the negative results. So cos x, cot x and cosec x, these three are the trigonometric ratios which are starting with C. So their derivatives are negative. So once more, we try to remember them. Differentiation of sin x will be cos x. Differentiation of cos x will be minus sin x. Differentiation of tan x will be sec square x. Differentiation of cot x will be minus cosec square x. Differentiation of sec x will be sec x tan x. Differentiation of cosec will be minus cosec x cot x. Now, differentiation of e to the power x. It will be e to power x. Hope with the first principle we have done this, you remember. Differentiation of e to power x will be e to power x. Differentiation of log x will be 1 upon x. Differentiation of log x will be 1 upon x. On Saturday, when we were doing this question with the first principle method, at that time only class was over. ddx of a to the power x. Previous formula was x to the power n. Now is a to the power x. It will be a to the power x log a. A to the power x log a. And this is different from x to the power n. Both are different things. This could be a to power x could be, let me show you one example. Like we have been given, we need to find the derivative of 2 to the power x. So it will be 2 to the power x log 2. Hope you are able to understand. A is some constant over here. A is some constant over here. Now, there are two very important formulas. Two very important formulas. These two formulas we are going to see. These are differentiation of u into v. This is first function. These are two functions. Two functions are in multiply. So, first function u differentiation of v plus v differentiation of u. u ddx of v plus v ddx of u. Like this, you must try to remember. First function differentiation of second plus second function differentiation of first. So as per your convenience, you have to learn this identity. One more is differentiation of u upon v. Differentiation of u upon v. So v ddx of u minus u ddx of v upon v square. It is differentiation of u upon v is v means denominator. Let me say like that only. Denominator ddx of numerator minus numerator ddx of denominator upon denominator square. As per your convenience, you have to learn this identity. This is really a wonderful identity, and you must be able to do questions based on it. So take care of yourself and you must learn this identity. Now we are going for the further things. One or two questions we are taking based on it. Like 13.2, very first question I'm taking, find the derivative of whatever we need to find derivative, that is differentiation of, I'm writing that as y. So y is equals to x square minus 2. We need to find its derivative. So that will be dy on dx is equals to ddx of x square minus ddx of 2. The differentiation of x square will be 2x minus differentiation of 2 will be 0. They said we need to find its derivative at x equals to 10. So we need to put now x equals to 10. So dy on dx at x equals to 10 is 2 into 10. That is 20 will be the result. It was the very first question. One thing you must keep in mind, whenever in the question they are saying using first principle, then only you need to apply first principle method. Otherwise, directly using the formula you can do. Keep in mind, whenever the question is asked using first principle, then only go for the first principle. Otherwise, directly you should do the question. Now, second and third question is very easy. I'm going to do fourth question. Fourth question, two parts I'll do. Two parts I'm taking one as second. Y is equals to x minus 1 into x minus 2. See, we are finding two functions are in multiply. That is u into v. So differentiation of u into v, I suppose you remember first function, differentiation of second plus second function, differentiation of first. Must see u ddx of v plus v ddx of u. So dy on dx equals to first function, that is x minus 1, differentiation of x minus 2 plus x minus 2 differentiation of x minus 1. Try to see x minus 1. Differentiation of x will be 1 and 2 is constant, its derivative will be 0, plus x minus 2 differentiation of x will be 1 and differentiation of 1 will be 0. So it is coming x minus 1 plus x minus 2. That is 2x minus 3. If the same question we want to do with some other technique, then see, this could be done with another way also. It is y is equals to x minus 1 into x minus 2. So I could open the bracket also. Y will be x square minus 2x minus 1x plus 2. I could also write it y is equals to x square minus 3x plus 2. Now it's differentiation. So dy on dx equals to x square will give derivative as 2x minus 3x, 3 derivative of x will be 1 plus 2 is a constant term, its derivative will be 0. So it will be 2x minus 3. So the differentiation using the formula or simply both will be giving 2x minus 3 over here, as well as in this also it is 2x minus 3. So differentiation, you are applying the identity or simply, or you are going with the first principle, you will be getting the same result. Now third part I am taking, this is y is equals to 1 upon x square. Y is equals to 1 upon x square. So its derivative we need to calculate. I could also write it y equals to x to the power minus 2. I am writing it y equals to x to the power minus 2. Now its derivative will be dy on dx equals to ddx of x to the power minus 2. So minus 2 upon x cube. So I suppose you are able to understand this question also. It is really a very wonderful, easy question. So similar type of questions are going to be asked in the exams also. Main thing is you must be knowing the identities. If you are knowing the identities, you will be able to do these questions. If you are not knowing the identities, you will not be able to attempt. Next, one more I am doing from the same topic. That is fourth question, fourth part. It is y equals to x plus 1 upon x minus 1. Keep in mind, this is u upon v rule. That is quotient rule. Quotient rule is differentiation of u upon v is v differentiation of u minus u differentiation of v upon v square. So let us apply this identity into the question. So dy on dx equals to denominator, that is x minus 1, ddx of numerator x plus 1 minus numerator x plus 1, ddx of denominator, that is x minus 1 upon x minus 1 to whole square. It will be x minus 1, differentiation of x will be 1 and 1 will be 0, minus x plus 1, differentiation of x will be 1 and 1 will be again 0, upon x minus 1 to whole square. Keep in mind, if I was not knowing this identity, I was not able to attempt this question. So fully it is depending on the identities. If we are knowing the identities, we will be able to do the question. X minus 1 minus x minus 1 upon x minus 1 to whole square. This implies minus 2 upon x minus 1 to whole square. So this is the result of the derivative x plus 1 upon x minus 1. So I suppose we are able to do this question also. It's really a wonderful question, and if it is coming in the exams, then also it's good. So take care of such type of questions. Mainly questions are given of this kind only. The two ways of the questions is, either you need to do the question with the first principle. If it is asked to you using first principle, solve the question, then only go for the first principle. Otherwise, you have to do directly. So it is as per the condition, whenever whatever is required. Now one question is, it is in front of me. Y is equals to sine square x. This could be done with the two different techniques. So first way is y is equals to sine x into sine x. The derivative of sine square x can be written as sine x into sine x. That is product rule we need to apply now. So dy on dx equals to first function sine x ddx of cos x plus cos x ddx of, sorry, my mistake. First function differentiation of second function is also sin x. I don't know why I thought it is cos x. Then differentiation of second function, that is, sorry, sin x, differentiation of first, that is cos, sorry, see, again cos, I am thinking. So sin x differentiation of second function, that is sin x, then second function differentiation of first. So it is sin x, differentiation of sin x will be cos x plus sin x, differentiation of sin x will be cos x. So sin x cos x plus sin x cos x equals to 2 sin x cos x. And 2 sin x cos x is one of the identity, that is sine 2x. So this is the question. Tomorrow we will do the same question with another technique. For today we have done the question with one of the method. So tomorrow we will see with another method. Piyush, you can stop recording. Let me talk to the students.